Okay, good afternoon, everyone. My name is John Scruggs, IT manager at Hobart Service in Troy, Ohio, and chair of Technology First's Infrastructure Cloud Special Interest Group. I'd like to extend a very warm welcome to each one of you here today with us for our 14th annual Taste of IT conference. Please join me in thanking our sponsors at the Diamond level, Cincinnati State, at the Gold level, Cadre Checkpoint and Okta, at the Bronze level, 8451, ComSpark CDO, CyberRabbit, Dell, Exagrid, Extreme Networks, Franklin University, Gigamon, Nexagen, Sinclair, and Smart Data. And to our annual partners, ATC, Affidance, CareSource, Cincinnati Bell, Google, Round Tower, University of Dayton, Wright State University, and Uptime. We couldn't do this without your support. Thank you so much. Okay, let's get started with our session. Today we have AJ Kuftic, Principal Technologist for Expedient. AJ has 15 years of experience as a customer and partner helping end users build solutions that are sustainable and easy to manage. Having knowledge across various silos of IT infrastructure gives AJ a unique perspective of the pain points and what customers are looking to improve. When AJ isn't thinking about the next big thing, he spends his time with his wife and 2 children trying to find the best scoop of ice cream. Join me in welcoming AJ Kuftic Expedient as he discusses how to prepare for the future of multi-cloud.
Thanks, John. Yes, I do search for the best ice cream. It's been very hard this year, but we're working on it every day. I do want to thank all of you for attending. My name is AJ Kuftic, as John mentioned. I'm Principal Technologist with Expedient. Today, I want to talk about how the future of multi-cloud is coming and how we can all as a group prepare for it. Also, just as a quick note, on the right side of the screen there is a Q&A panel. Please feel free to enter questions as you'd like. We're going to keep track of those questions and make this a little interactive so we can answer your questions and see how we can help you. Before I talk about cloud, I really want to talk through the concept of work. And I know that this is a work day, so we're all thinking about it, but coming to a conference like this is really helpful to understand more of the bigger picture. But when we think about work, there's 4 main buckets that work lands in. At the top left there, we have our business projects. These are the things that generate revenue. These are the things that are new features. The business comes to us as IT and says, how do we do this thing that we want to go do? We want to maybe enable bulk shipping, or we want to make our routes for shipping more efficient, or we want to get a hold of our data and understand where our customers are coming from and how we can reach them more effectively. That's where IT really makes its bones in terms of being able to have an impact to the bottom line of the business. On the top right, we have our internal projects. These are the things that we as IT do to make things better, not just for the business, but also for ourselves, especially things like architecture changes from 3-tier to hyper-converged, or from on-prem to cloud, from legacy apps to modern apps. These are the things where maybe there's not a direct impact to the bottom line, but there's an impact to IT's ability to deliver those services to the business itself. On the bottom, we have unplanned work. And this is the stuff that goes bump in the night. These are code defects. These are changes that go in, and maybe something downstream didn't realize this change was going to affect it, and it did. And now there's time spent fixing the actual problem and not making any sort of real improvements. This is also when servers go down, RAM goes bad, switches are down, storage is down, those sorts of things. And this is work that you can't really plan, but it's still work that needs to be done to keep the lights on. And finally, we have planned work. And planned work is the stuff that that you're going to do next year right now. Things like hardware refreshes and patching and logs and audits and all of the stuff that you have to do year in and year out, month in and month out, to keep the lights on for the business. And this is all stuff that way, way in advance, and it's usually stuff that lands in the budget. But when we group these a little bit higher, the business projects and internal projects form what we call at Expedient high value work, or AC work. And if you think about a grading scale, right, A to F, A and C, AC work is stuff where If you do really well, you get an A, you get a kudos, you get hopefully some extra compensation, but you'll get mentioned in a newsletter, mentioned in an all hands meeting around how you and your organization helped the business move forward and generate more revenue or be better overall. If you don't do a great job, you get a C. You get, there was an effort, you put forward an effort, but overall, it didn't really work out for us. On the bottom, unplanned work and planned work is what I like to call low value work or CF work. And this is not no value work. There's definitely still a value in keeping the lights on, right? There's still a value in maintenance, but it's not as valuable to the business from a bottom line standpoint as the high value work. And it's called CF work for a reason. If you do it well, you get a C. You did the job you were expected to do. Right? You did the thing. You patched the servers, and patching went well, and no one noticed. Great job. If you fail and that patch blows something up, or your change takes down the storage array for a day and the business can't do anything, that's an F, and F is for fired. So when we're thinking about this, and when we're thinking about that future of multi-cloud, think about the types of work that you could do and the type of work that you would likely get rid of and the time that you would save doing that. So when we talk about cloud, we kind of have to start with why. Why cloud? Why now? What drives this forward? The first is agility. This is a very good boy doing an agility course. And what that agility provides, first and foremost, is a faster time to market. I want the ability to pivot to meet changes in the market, right? We're all sitting at home now. We all have a bunch of quarantine going on, yet the holiday season is coming up. So you know that online ordering is going to be much higher than it has been in the past. Shipping times are already starting to creep up. I got 5 emails from a bunch of different places I've bought stuff from that says, hey, if you want to buy stuff for Christmas, it's probably going to take a little bit longer to get to you, so order now. All of these things are pivots that these businesses have had to make to be able to sustain their business. Back in March, Target, Walmart, Lowe's, Home Depot, pretty much every restaurant, coffee shop I could think of, all went to curbside pickup, all went to delivery. The state of Pennsylvania enabled people to get drive-through cocktails. It was a thing. People have been fighting to change the alcohol laws in the state of Pennsylvania for decades, and overnight it just happened. But these were the sorts of things where things needed to pivot to maintain this and sustain the business, because you can't have people come into the store anymore, or people don't want to come into the store anymore. And when that happens and you're not able to make that pivot, it can be a problem. Take IKEA, for example. I love IKEA. Most of the furniture that I have in my house is from IKEA. But when quarantine started, IKEA didn't make any pivots. And if you've ever tried to buy something on IKEA.com, you know that that's not exactly the most straightforward process. And when they went back to trying to bring orders online, their delivery times were 6 to 8 weeks out. And people were saying, well, why? There's a store down the road from me. I could go get it right now. I know it's in the store. I saw it last week. I just can't go in it now. Why can't I just order and pick it up from the store? IKEA didn't pivot, and they lost millions of dollars in the process. So this agility and the ability to have a faster time to market for changes is incredibly important. And speaking of that holiday season, this provides a ton of scalability. Right now, we're entering, it's the middle of November. Black Friday is next Friday, I think. And so we're now getting to the big holiday season where all of these retail organizations are starting to need to spin up more resources to be able to support all of this online ordering that we're now going to see as part of COVID. They've started already. They've tried to make sure that all the resources are in place and load tested it to make sure that their website doesn't fall down on Friday morning, because that's now their main storefront. And this scalability that we're talking about is not something that's new. It's not something that's just a technology thing. This is the same thing these retail organizations have been doing with people since the start of time, right? It's the holiday season. These are our seasonal workers. We're going to bring in more people to support all of the customers that are going to be coming in the door. This is the new doorway. And so that scalability really enables that. And finally, this is the opportunity, business-wise, to make the switch from CapEx to OpEx. Because agility and CapEx, they don't go together. And the reason for that is CapEx is a big purchase. You are acquiring a thing, and you have to own it and maintain it for the next 3 to 4 years until you can get rid of it. It's not something you're going to buy and then hold on to for a month and then get rid of. And so by making that switch from CapEx to OpEx is a big deal. And as you start to look into cloud and multi-cloud, having these conversations with your finance departments, with your CFO, is incredibly important for them to understand the change in IT spend and IT purchasing that will happen. Because if you don't, they're going to say, well, hey, your capital budget's huge. Why is your OpEx budget growing? Oh, well, because we're doing everything in the cloud now. We don't need the capital budget anymore. These are the sorts of things they need to know up front because it'll make it a lot easier for you going forward. The other one here is operations. And when we look at operations, this is your big opportunity to retool. Because a lot of people, especially at the engineer level and the developer level, start to get concerned that this is going to take their job or that they're not going to be needed anymore. Because the thing that they've done forever is maintain servers, maintain storage, maintain, hardware networks. And now they're saying, well, it's all out there. I don't need to deal with this. This is the opportunity to retool. This is the opportunity to retrain. This is the opportunity to reorganize to better support your business and your applications going forward. This is why DevOps is such a big piece of cloud. And I know that a lot of people kind of roll their eyes at the concept of DevOps, but when we look at things like being able to take on a new platform and operationalize it versus having to own and maintain it, there's actually a big jump there. And so by taking this opportunity to retool and focus on how you're going to go do cloud, it's going to make it a lot easier and a lot better for your organization. This is also the opportunity to begin to automate and automate and automate. Is that automated? It should be. Because as you start to move forward, having somebody going around clicking a mouse to scale up and scale down could potentially be costs that are going out the door because somebody didn't get to it fast enough, or this thing ran for too long, right? You want to be able to automate that and make it all that much easier. And finally, lines of support need to be drawn. If you're a colo customer, if you are a third-party data center customer, you already have sort of kind of this idea of where your ability to support things stops and where the provider's ability starts. And so you're aware that, like, when you go into a data center that you don't own, you have to be escorted to your cage. Even though it's your cage with your stuff, you have to be escorted there. And they handle the power, they handle the networks, they handle everything facility-wise. If you've always owned your data center, understanding where the lines of support are and where your ability to support your platform stops and where theirs starts is incredibly important to understand out of the gate. And this is something that becomes a challenge for a lot of organizations because they're used to being able to just walk into the room and go do it. So understanding those and understanding your time to support is very, very important. So when we're talking about cloud, there's a number of different terms that come along with the concept of multi-cloud. There's hybrid cloud, there's multi-cloud, there's private cloud, there's public cloud. So I just want to clear everything up here so we have an idea of what this actually looks like. On the right, we have a couple drawings here. Multi-cloud is when you have two public clouds that talk to each other. Hybrid cloud is where you have maybe your private cloud or on-prem environment talking to a public cloud. And multi-hybrid is where you have a mix of the three. For the sake of this, we're going to refer to everything as a cloud, and we're going to say that more than one of them is multi. So just to clear all that up from a terminology standpoint, this is a general industry terminology, but for the sake of this, we're going to just call it multi-cloud. When you're looking at this, how do we consider how to handle these sorts of technologies? The first is connectivity. Because now you're starting to take your data center, especially if you have it all on site right now, and you're moving it out. So now your connectivity becomes a critical access point for not just your end users in the building, but for your end users out in the world. And so how do you make sure that your data center is going to be able to get to those clouds? You build disparate paths. And when you're thinking about that connectivity, there's the egress costs as well, especially in a hyperscale cloud where you have to deal with the egress costs or the egress fees coming out of some of these services. And where does that data live, right? If your data lives in a hyperscale cloud, but your application still lives on-prem, you're going to be pulling a lot of data out and paying a lot of money to bring that out. Migrating the application as a whole and minimizing the amount of data traffic that has to go into and out of that cloud for that application just to run is incredibly important. And then making sure that your users, as they're using those services, are accessing them in the cheapest and most cost-effective way possible. So by understanding where your data is, where your data flows are going, and how to actually make that all work connectivity-wise is the most basic consideration that you need to make. And once you figure out your networking connectivity and how these applications actually talk to one another, you have to understand the capabilities and tooling that you're going to put around them, right? You're still going to monitor things. You're still going to have to provide some sort of identity to that. How do you handle logging? And how do you provide it in a consistent view? One of the challenges with the hyperscale clouds is that there's a very clear hierarchy and priority to cloud tooling. AWS is number one, Azure is number two, Google sometime next year, pretty much across the board. And it's one of those things that as you are looking at this, sort of platform, is understanding where you're going to land things. You may have the idea that, well, I'm going to use all of them. I'm going to put in AWS and Azure and GCP, and I'm going to use all three of them. Does your tooling support that? Do the capabilities of each one of those clouds make it worth using it in the first place? So when you're looking at things, are you using it because there's a specific capability in that cloud, or you just want to be able to say that you're using all of them? It's cool to say that you're using all of them, but you're going to add a lot of pain to that process. So when we're choosing clouds, we could pick a cloud. They're all the same, right? Not entirely. When we look at these sorts of clouds, we're looking at things like hyperscale clouds. And when we look at hyperscale clouds, they're really great. These are AWS, Azure, GCP. They're really great at things like new development. New development like functions as a service and database as a service, taking your applications and just being able to take on these services that exist already without having to go build database servers or go build app servers or go build logging or anything like that. All of these services already exist and you're able to just go take advantage of them. There are differences between them though. So when you start to get into the actual services and what those services actually do, understanding the services capabilities and comparing the two, right? Amazon has VMs, Azure has VMs, Google has VMs. They all have, right? They all have logging, they all have networking, they all have DNS, they all have these various things, but there's subtle differences to them, and understanding what those differences are can be a big deal. If you're going into, say, and you want to go out there and you want to use something like SQL Server, Azure does SQL Server as a service, whereas Amazon has RDS that can do SQL Server, but it's not the native function, right? It's the same thing with maybe Amazon does Postgres really well, but Microsoft doesn't. The ability to understand those subtle differences is going to be very, very important. So as you're building your new applications, you're building them in the best way possible. Next, we have our native platforms. And a lot of times these native platforms are the sorts of things that are very difficult for you as a customer to build on-prem and use cost effectively, right? It's not hard to go buy a bunch of hardware, right? That's decide what servers you want, decide what GPUs or TPUs you want, buy them, put them in the data center, run them, right? It's not hard to go build it, but it's hard to build it and only use it as you need to. You have to have a workload or a need strong enough to say that I'm going to have enough workload that it's going to be constantly running, that I don't want to just pay for one use, I want to just pay for its use forever. That's not always the case, especially as you start to build some of these platforms, things like big data. Big data needs a lot of storage and a lot of compute to go with it because you're doing a bunch of analysis of unstructured data. So being able to take advantage of existing platforms that exist in these hyperscale clouds already means that you don't have to go build it and figure it out and then figure out how to maintain it going forward. You just go out there and use it. Your data scientists, your analysts, your consultants already know these technologies. Just let them go use them, right? This is the same thing that we already build on top of from a VM standpoint, right? If you're a customer and you have a VMware environment on premises right now, building another VM isn't that big of a deal, right? Building a VMware platform is something that you did to support all of your servers. And when somebody wants another one, you could just go build that because you're paying for the use of the overall platform no matter what, because somebody's going to use it. In this instance, not everybody in your business is going to use those native platforms. So being able to take advantage of them and get started quickly is really great, not just for as you go forward, but as you want to test things out. Maybe you've got somebody who wants to do a big data, they have a big data idea. Instead of going out and spending $1 million on hardware, they go out, they consume the service and say, hey, this really worked. We should keep doing this. Or that didn't work at all, and I'm glad we didn't spend $1 million to do that. And they put it away. Hyperscale clouds offer a ton of elasticity. This gives you massive scale. And they're able to do this because they have many, many customers that are constantly paying them. If you're not using it, somebody else will. And so by having this capability and all of these existing resources, they're able to build a platform where you can just come use them, build out something huge, use it, and shut it all back down. This is why cryptocurrency people love people leaving their credentials out on GitHub, because they can spin up an entire cryptocurrency mining organization, and if it gets destroyed, oh well, we'll move on. This is all powered by that true pay-as-you-go. That meter is running. It's like your electric bill. This light that's on in front of me, my lamp over here in the corner, my computer, and everything that's here, this is all using power as long as it's powered on. If I leave this on and I go downstairs to have lunch, it's still using the electricity, so that bill is still rolling. So be considerate of your usage and only use things out in a hyperscale cloud where you know you can spin it up and shut it back down. You don't want to spend your entire electric bill running something that doesn't really need to run all the time, right? This is the dad pro tip of this is why dads turn off all the lights, because they know the meter's constantly running. Be a dad who hates lights. And finally, your SLAs. This is something to consider when you're looking at a hyperscale cloud. Understand the SLAs that these clouds have. It is usually something like in the 99, maybe 3 or 4 nines. And that may or may not line up with your business, right? And the way that the redundancy is handled in the platform may or may not line up with the way that your business does business. You may say, hey, we're putting our VM out there. It's an EC2 instance now. Great. If that host dies, you just get an email from Amazon that says, oh, host died. Sorry about that. You should probably go turn that back on. Meanwhile, you're down wondering what happened to your server. So the ability to understand the redundancy and how to build that in to make sure that you have a highly available platform. It's not just going to automatically reboot on another host. You have to go do that yourself. Congratulations, you're a vSphere HA now. And finally, looking at all of the SLAs of your storage. Various hyperscale clouds, I'll pick on Azure here, have an SLA per tier of storage. And so they may say that this tier of storage has a 99.9% uptime. That's the SLA on it. Everything else doesn't have an SLA. If it's down, it's down. So consider that. Don't just pick the cheapest thing. Consider those things and understand your SLAs across the board. So there's another type of cloud, and that's enterprise clouds. That's us as Expedient, that's Rackspace, that's TierPoint. And so we have a number of other capabilities. The first is that enterprise clouds are really, really great at existing applications. All of those clouds that I referred to, Expedient, Rackspace, TierPoint, are all VMware-powered clouds. You can take your VM, migrate it to an enterprise cloud, no refactoring. You can leave them powered on 24/7. It's powered by the resource pool. It's not powered by the individual instance. So you can have a resource pool and you're paying for those resources every single month, and you don't have to worry about whether or not the lights are on or the lights are off. It's just a predictable cost. It's like being on the budget plan with your electric bill. You know you're paying a standard amount every single month. This also leads to flexibility. All three of those providers are all previously co-location companies. In fact, they still are co-location companies. You can put your stuff into Rackspace or TierPoint or Expedient, especially if you have things that are like physical database servers, mainframes, AIX, HPUX. Being able to bring that legacy hardware in is actually a benefit, because even if your CIO says you're going to the cloud tomorrow, I still got this big mainframe and I still got all this legacy hardware, and I have to do something with that. What is the plan for the rest of it? You can also bring over your current platforms. So you can take advantage of the fact that there's a data center you can land in and have direct connectivity into your VMs so that you don't have any extra latency or any extra bandwidth problems. You can just bring it all the way in. Doing this with a hyperscale cloud is actually not terribly hard, but it's also not terribly easy either. You either have to go out and build direct connectivity from your data center to the hyperscale cloud, which means you're not gaining any sort of real efficiencies in terms of facilities or management. Or you have to pick your hardware up and put it into a point of presence like Equinix that also has a direct connect. And so you now have this sort of disjointed solution. By having it in one data center, here's your legacy stuff, here's your current stuff, all of it is together under one roof and maintained. And then from a support standpoint, you have in-person or phone support. Hyperscale clouds, unless you're a big customer, likely aren't going to give you a sales team. By having an in-person sales team that can meet your needs and hear what you're saying can actually go a really long way. You have a voice into the cloud. And then from a managed services standpoint, this is where you can extend those things and do things like OS patching, right? That stinks every single month. Month after month, you're going to do it. You can have an OS management service that takes care of that for you. You can have managed services around your network, around VPN, and the ability to scale that up just as well as you can your VMs. All of that support goes along with that. And finally, the SLAs are at the hardware level. These are based, again, on that technology. So it's still vSphere HA. So if a host fails, your VM reboots and you're back up and running. You have a higher uptime. And at least with Expedient, we have a 100% SLA because we believe that we've built a really great platform and we stand behind it. And if there's a service outage that causes a problem for you as a customer, you get a service credit. It's that simple. So being able to take advantage of a lot of these things can go a very, very long way. Enterprise clouds and hyperscale clouds each have their pros, they each have their cons. And so building this multi-cloud future can sometimes be a challenge. And so this is where the cloud native journey starts to come in. There's three real ways that you can go on this cloud native journey. You can go on them in order, you can go directly to the end, or you can kind of jump around in the middle. It doesn't really matter. It's all about your applications. They're what's going to drive your journey. So the first is rehosting. This is picking your existing platform up and setting it down somewhere else. And so this is the simplest way to do it, and it takes the shortest amount of time, right? It's just a migration, right? 1 to 3 years, very inexpensive. In the middle, we have replatforming. And replatforming takes a little bit longer. This is where you start to take advantage of some of those native services, and it costs a little bit more, but you start to gain more of the benefits. And finally, refactoring. This is the big bang. This is the rethink. And this can take a very long time, 5+ years, and it can be very, very expensive, both from a financial standpoint and from a people standpoint. But this is where you are modernizing and being able to drive it forward. So let's dive into this a little bit and understand the deeper kind of concepts of each of these. The first is rehosting, and this is where the phrase lift and shift comes from, right? This is moving your existing couch, right? You've wrapped it in plastic, you're taking it out of the room, you're going to move it to your next apartment, your next house, because you happen to like that couch. The couch is still very comfortable. You just bought it maybe a year or two ago, and you're able to just reuse it in your new place, right? No big deal. The cost is very small to do that, but there's also no cost optimization. That couch may fit this room now really, really well, but your new apartment or your new house has a bigger room and now this couch looks super small. Or maybe your family is getting bigger and that's the whole reason you're buying a new house and this smaller couch doesn't fit your family anymore. So being able to optimize is very, very difficult with rehosting. And so this has the smallest benefit from a cloud native standpoint. When you're looking at your virtual machines, you're able to pick those up and migrate those over to something like an enterprise cloud or maybe VMware Cloud on AWS. And so the value proposition isn't so much that you're moving for the sake of making a huge change, but you're just trying to optimize your basic infrastructure. So there is still a benefit there. Next is replatforming. And when we're replatforming, this is where we start to use native platforms, right? We have a bigger room, so we're going to go buy a bigger couch. And so as you start to lay these all the way out, you start to build on top of these native platforms. Maybe that's database as a service, maybe that's functions as a service. And being able to have this better outcome overall for your platform can go a really long way. So as you start to take on those native platforms, this is where you take your application and you start to modularize it. You start to say, hey, you know what? This website that we have doesn't need to be a big monolithic architecture. We can say, oh, hey, here's the order tracking system. All right, let's pull that out and make it its own module. And by making it its own module, you're able to upgrade that and do it in a much smoother fashion without affecting the rest of the website. Let's say you take on a new carrier and you want to make sure that that carrier, you automatically get tracking numbers and they automatically get emailed to customers. You can do that just through the order tracking system without affecting the rest of the platform. This is also the best opportunity to start to automate. As you're doing your new builds, as you're building these modules, you're capable of taking on new automation and new build processes. So when you say, okay, we're going to push all of our code into GitHub, that new push into GitHub and that commit creates a new build and the application redeploys. Excuse me. So as we're replatforming and we're taking on these new platforms, what's a better way? What's the best way we can go do that? This is refactoring. And by taking advantage of those native platforms, we can start to say, hey, this worked out really well for the data platform, or this worked out really well for the app platform. How can we make the web platform better? Or how do we make this so that this is more highly available? How do we take this legacy platform and bring its functionality into new technologies? This is the complete rethink of the application. And especially when you're coming from a legacy platform like maybe mainframe or AIX or HPUX or even VMs, you can start to run into challenges around things like technical debt or staffing issues, especially if on the mainframe side. If you've seen mainframe teams lately, they're a whole lot, most of the team is far closer to retirement than they are to being new hires. And so by doing this and you start to modernize those applications, you're not just modernizing the application for the end user, you're modernizing the application for yourself and your IT organization so that you can support it going forward in the future. And so this can seem really, really scary. And in some ways it kind of is. But in the process of doing it, you're being able to find all of the skeletons in the closet. You're able to find all of the issues and either be able to fix them or modernize away from those problems to make the application better going forward. This is what provides the most benefit overall. So how do you use more than one cloud, right? We've talked a lot about the differences in clouds and how do you pick a cloud or how do you, move your applications to the cloud. And really, there's a path to multi-cloud, and that's containers. And when we're talking about containers, the first thing we're doing is we're talking about abstracting the application from the operating system, right? So if we're thinking about the virtualization and how we moved from physical servers to virtual servers, what we did was we abstracted the operating system away from the hardware. And so we're able to move that operating system around. Now we're up here at the operating system layer and we're abstracting the application up away from that. And so what that means is that I now have the capability to modify my application or scale out my application without having to worry about what's going on the bottom at the operating system or kernel level. And so this leads to things like Kubernetes everywhere. And if you haven't noticed in the industry, this is kind of happening a lot, right? I've got Amazon's Elastic Kubernetes service. I've got Azure Kubernetes service. We've got Google Kubernetes Engine. We at Expedient have our own enterprise cloud native platform that's powered by Kubernetes. VMware now has Kubernetes inside vSphere. It's kind of a thing. And so being able to take that on and enable that for your developers and thus your end users is going to go a massive, massive way. This allows you to re-platform without completely refactoring, right? You can take your application and just start to break it down into little chunks. You're not refactoring it. You're not rewriting the code. You're not really changing much. You're just moving to a smaller and more modular platform. So what does that look like? It looks like this, right? On the left, from an infrastructure standpoint, this is a very traditional VM-based platform, right? I have server hardware and I have a hypervisor, and all of that is the same across the board. And I have a RHEL server because maybe the first of my standard is RHEL, and so I built that, and that application lives on top, and its libraries and drivers are at that operating system level. And then when App 2 came in, I have my Ubuntu operating system because the second developer was like, no, I really like Ubuntu. I really want to use Ubuntu, and it's just better for me. We've all been there. And you deploy the new libraries, you deploy the new drivers, you deploy that application on top of that. But now I have to figure out how I'm going to patch RHEL versus Ubuntu. That's two different base platforms for patch management. And then finally, the third application came in and that developer said, I want CentOS. And I'm like, well, I have RHEL right here. And they're like, no, I want CentOS, open source forever. Again, you've been there. And by building this third application, I can kind of use my same tooling from RHEL, but not entirely. And now I have 3 different sets of libraries and drivers, 3 different applications, and 3 different operating systems. And now I'm chasing my tail from a maintenance standpoint, trying to keep up with all of this. Because in theory, I could collapse all of these down onto the first VM, but in doing so, I'm going to start to have library and driver collisions, right? If I have Python 2.7 and the app 2 needs Python 2.8, I can't upgrade Python because I don't know what it's going to break on app 1. And so this is the whole reason why we have this VM sprawl for all these various applications, because we need to be able to support all these various little prerequisites and libraries and drivers to make sure these applications work and are stable. On the right, we have the container world. Again, same server hardware, same hypervisor, but now the developers don't care about the guest operating system because there's a container engine now in the middle. And so now I can place my guest operating system of RHEL, and I'm going to support RHEL, and it makes my patching life easier because now there's 2 less operating systems to deal with. And now I have my container engine. And all of the libraries and drivers are all inside of those individual applications. And so now app 1 can have Python 2.7, app 2 can have Python 2.8, and I don't have to worry about driver or library collisions causing those issues. And as part of this is where I can also change some of my processes to be able to support these applications going forward. So I don't have to worry about, I need to go out and patch Python for them. I can say, hey, your libraries and drivers are inside of your app. You deal with patching, and that's part of your maintenance processes as part of the application. You're now giving more control to your developer while not really having to take on any sort of secondary responsibility around that. It's all on them. And so instead of having VMs versus containers, I just focus at the container level because the rest of it doesn't actually matter, right? The operating system and the hardware on the bottom doesn't really matter to the developers. They don't care. They're just focused at the container engine level. They're focused on their libraries and their drivers, and it makes their life that much simpler. And from a CI/CD pipeline, this allows me to be faster. I can have things like building and coding, or planning it and coding it and building it, and I can deploy that into a new container and just mess with that little one that's based on the same code base that's running in app one, but I can see what changes happen. Or I can start to roll out different versions of app one and do blue-green test deployments. So I can say, hey, here's 4 containers that run our website. I'm going to take one out and I'm going to put the new version on container 4. So new container 4 rolls out, and as users hit it, they might get a slightly different version of the website. And if there's a bunch of issues with those, I can pull that out and deploy the old container back in, and I can fail quickly and understand what happened with that with an actual user load and go, okay, that didn't work out. Let's try that again. And I can make sure that my changes are going in as smoothly as possible. The other thing this does from an operational standpoint is that I'm monitoring at the container engine and container level, and I'm not really sweating what's happening on the bottom, right? The rest of my environment may care about that, and I care deeply about the operating system and the hypervisor, but from an operational standpoint, I'm really only focused up at this top level on how these things get deployed and whether or not they've crashed. So that's a big way for you to make that move towards multi-cloud and be able to have consistent operations across all of them. So what does this all mean? Right? We spent a lot of time talking through various technologies and various reasons why you would do things. But if we really think about this from the business standpoint, they don't understand physical hardware. You care about it as an IT person. You care about virtual machines, and you care about cloud native. But at the top are the applications. And from the business's standpoint, this is all they care about. This is what your business wants. They don't care about anything else that goes on below that layer. And they care about their applications. And all of the work that you're doing on your platform today needs to be focused on how to make the applications run as best they can, be available as they can be, and be as agile for the business so they can make the best move forward possible. So from a takeaway standpoint, cloud is obviously a massive transition. And it's more than where you run your applications. It's how you run your applications. You can do these same sorts of things on premises. You can do these with hyperscalers. You can do them with enterprise clouds. But understanding the changes that cloud makes to your applications is a massive, massive deal. Cloud also offers the opportunity to make large changes to your platform and your operations. And what that means for your business is that you're able to respond faster to their needs. Take the opportunity as part of a multi-cloud journey to be able to take on these capabilities and these platforms to move your business forward. And finally, this is not the best ending for most people, but there's no right way to do it. There's no A, B, C, and it's guaranteed to be D, right? There's A, B, and C, and it might turn out to be G, right? There's no right way to do it. Your applications and your business will dictate this journey. And focusing on those applications in the business is going to be the best way to move forward. Just going out and swiping the card and saying, we've got an AWS organization, let's go, doesn't necessarily mean that the applications in the business are ready for that. Have the overall conversation with everyone and be able to have a successful migration. And with that, I will open it up for questions. I'm looking in the chat, looking in the Q&A here. Anybody out there have any questions? I'm more than happy to answer them here. Over on the right side of the panel is the Q&A.
Yeah, and for those of you watching on YouTube, remember to go back to the Socio app to enter in your questions and answers. So there's one there, AJ. Do you see your ice cream recommendation?
So I'm not in the Dayton area. I got to go to Dayton back in January, pre-COVID, which was a delight. So in terms of ice cream, I'm going to go just flavor-wise. I'm a cookies and cream person, but I'm always a sucker for peanut butter and pretzel. Jenny's ice cream out of Columbus, their Buckeye ice cream is incredible. So I'm usually here for big flavor, but a good vanilla is actually something that's very, very hard to find. If you can find a good vanilla, that can go a long way. It makes pie better. So there's some ice cream recommendations for you. There's my ice cream takes. Also gotten a lot into bread. Highly recommend baking your own bread. You make your house smell nice, and then you have better sandwiches. Just go bake your own bread.
That was worth it right there with the ice cream recommendation and the bread. So
yeah.
I don't see any other Q&A coming in. AJ, did you provide some ways to contact Expedient or yourself?
Yes. So if you want to contact Expedient, you can go to expedient.com. There's a Let's Talk link up at the top of the page. You can also reach out to me, aj.kuftic@expedient.com. And you can reach out to me and we can email, we can talk, we can answer your questions. I see some folks out there that are either customers or we thank you for your business or are looking at us. So we do have a number of different options for you and your business to be able to bring a cloud operating model forward. We're not just an enterprise cloud. We also have direct connectivity out to the various hyperscale clouds, so we can help accelerate that cloud journey as well. So throw a little pitch out there.
All right, sounds good. AJ, thank you so much. We really appreciate you giving the presentation today. And it was very informative for me, and I'm definitely that dad that turns off the light switches in my house. So exactly,
be a dad who turns when you're thinking about cloud, just think about the lights being on in your hallway. Just think about that and go, no, I don't like that. That's how you do it.
Amazing. So also special thanks to Extreme Networks, who is our featured sponsor for this session. And everyone, remember to complete the survey for each session by finding the link in My Agenda session descriptions, which is the same place you click to join this session. By participating in the survey, you make your voice heard and are helping shape the future of Technology First events. There are some game codes you can earn by exploring the app, so go to the Event Game tab to learn more there. And the game code for attending today's session is Future. Thank you so much, and we'll see y'all soon. Is Future. Thank you so much, and we'll see y'all soon.